Hi, everybody. Good evening. Welcome to the December 2nd version of our virtual night sky programming. I welcome everybody. I see the participants are still joining. And I've got just a couple of minutes to introduce what we're going to be talking about tonight, but I wanted to welcome everybody. I also wanted to say that we know uh, from time to time that we have lots of students and we have some of the teachers that have taken advantage of some of our programming at ASU. And so part of this particular program is to keep in contact with people and make sure we don't lose any friends while we're not having visitors at the ASU campus. So thanks for participating with us. I can hear the wind howling outside my window. Okay, maybe it's not howling, but it's breezy and cold tonight. This is the first wintry night there is. I put my sweater on. You can tell that I'm ready for it. Um, in spite of that, nevertheless, we're going to talk to you tonight about some things you can go out and look at over the next couple of weeks. That's part of our practice. If you're new to this particular program, we spend about an hour every other week, and we talk a little bit about some all kinds of different variety of different subjects, astronomical in purpose. But we also leave everybody with some things to look for, some things to go out and do. Uh, and so last week, or 2 weeks ago, sorry, last time we had a program, we talked a lot about the moon and where it was. And I sent everybody scurrying outside to look at the position of the new moon and where it was in relation to the planets. And then you could watch that over a course of 3 or 4 days. So I trust some of you have done that. You can't chat with us, but you can put things into the question and answer part. And so if you did take advantage of that, if you wouldn't mind, just sort of send a little comment, say, yep, I watched the moon and we saw what it did. Then I also owe you a little bit of an apology for last week or 2 weeks ago. We did not talk about a minor lunar eclipse that happened about 3 days ago. If you were paying attention to the news, you probably would have known that just over the Sunday, Monday night, Monday morning, very, very early, 2:42 in the morning, there was a partial penumbral eclipse. And what all that adds up to and what that means is it's almost unnoticeable. Nevertheless, I set my alarm, I got up, I ran outside. It was cold, and I took a quick look to see what was going on. And uh, it was, I could just barely notice maybe some shadowing or some shading, but it wasn't a very dramatic lunar eclipse. And that one is over. We'll be careful about making sure that you can see the next phenomenon. Uh, at the end of tonight's program, I'll give you some other things to look for, but let me introduce how we're doing this tonight. This is kind of my vacation time. So I'm joining you tonight as the host, but we have turned the entire program over to students, at least the content part of the program. So you're going to be hearing from 4 different students at the School of Earth and Space Exploration. Alex Blanche and Liam Nolan are both astrophysics majors. They're undergrads and they're part of a very special group. They're also interested in cosmology. And they're going to take the first half of the program and walk you through a little discussion about the Hubble Space Telescope and ultra deep fields, how far that telescope can see. They're also going to leave you with a little tool that you can load onto your own computer and actually sort of look at that. So watch for that. That'll be the first half of the program. Alex and Liam will take that. In the second half of the program, a little bit closer to home and a little bit more observable, we are welcoming to the night sky the great constellation Orion. So Alicia Hyatt and Spruti Kachere are actually going to walk you through sort of some things to watch for, how to find Orion in the night sky. It's starting to appear. It will be with us for a little while. They'll show you what to look for, some interesting things about Orion, a little bit of some stories and some mythology about Orion, and that will kind of take up most of the second half of the show. At the very, very end, I'm going to give you a little recap, a little mission information to look forward to this weekend. We'll talk a little bit about what we're doing in 2 weeks, and we'll go on from there. So that's it. Welcome. Sit tight. It's going to be a great program, and I'm going to turn the microphone and your attention over to Liam Nolan and and Alex Blanche. Thank you, guys.
Thank you, Rick, for that introduction. Hi, everybody. My name is Liam Nolan, and as Rick said, I'm an undergraduate here at the School of Earth and Space Exploration. I'm double majoring in astrophysics and physics, and I'm minoring in French. I also work with the Space Grant Program, which Alex and I are going to talk about in just a little bit. I also work with Roger Windhorst Cosmology Research Group. And as part of that group, I do research into faint radio galaxies that are in a region of the sky known as the James Webb Space Telescope North Ecliptic Pole Time Domain Field, which is a mouthful, and you don't need to remember it. it's essentially just an area that a new telescope is going to be able to study, and we're going to talk about that more in a bit. I've also been doing research into the use of an educational tool called Appreciating Hubble at Hyperspeed, or AHA, which we're going to demo for you guys toward the end of our presentation. I've been looking at the use of this tool in the classroom in order to better promote engagement and enjoyment of astronomy education. I've also done extensive work with the Smithsonian Museums in both designing and presenting educational programs to the public. And one of the most important things to me is keeping the public engaged in space research because it's all such really cool stuff. I think that's enough about me. I'm now going to turn you over to Alex Blanche to introduce himself.
Thank you, Liam. So hi everyone, my name is Alex. You might know me from previous Night Sky presentations. I've been a part of our student docent team, so I'm in the background helping answer some of the questions that you guys have. But tonight I'm coming to you as another member of this cosmology research group headed by Roger Windhorse. I get to work with a lot of undergraduates like Liam. I get to work with graduate students and faculty and staff and research more about our universe as a whole. My specific research falls under the category of very specific radiation emitting from galaxies. So as an undergrad, I get to work with a postdoctorate student who actually graduated from ASU, and we're studying a very specific energy of radiation that is actually allows hydrogen to become ionized. You don't have to understand what that means. There's not going to be a quiz, but our current understanding of the universe is that it's ionized, and it's very important to us because, it's our universe. We want to understand how it got to be the way it was. And so myself and my mentor, Dr. Brent Smith, actually study this. And so like Liam said, he's part of Space Grant. I'm also a Space Grant intern. And so my project is a branch of that larger project, and it's looking at a more specific classification of galaxies and looking why some of these have these emissions of radiation and why some of them don't. So I get to study a lot about these galaxies and why they're emitting radiation and how they've shaped our universe to be what they are today. So Liam and I have both talked about Space Grant. I'm going to pass it back to Liam so he can tell you about more what that is in terms of, how we interact with the public, what that means for us students. So Liam, back to you.
Thank you, Alex. So something that you're probably going to hear a lot about actually in future virtual Night Sky presentations is Space Grant. And Space Grant is this joint ASU and NASA program where NASA funds undergraduates to do research with professionals at ASU, such as professors, other research people, and things like that. And it's a really cool experience for students in that we get paid to do research, which is pretty cool. And in addition, we get to do outreach and we get to share with the public the sorts of things that we're working on and really giving a better idea of what NASA is all about and what space research can look like. So that's kind of the set of benefits. There's an outreach component where you guys get to see the sort of research that's being done and see that presented in a very accessible way. But then we as students also get an opportunity to do research that otherwise can be kind of difficult to do during the year, and we get paid, so that's nice. And you're probably going to see many future scholars under Space Grant who are going to present their work as part of these different presentations. So moving on to kind of the meat of our presentation, we're going to talk to you guys about the research group that we're part of. So I'm going to share my screen. All right, hopefully that's visible. And we're going to be talking about the cosmology research group that we're part of. And we've both been part of this for me, I think 3 years now, and I think Alex too. And we've been doing work that involves the Hubble Space Telescope, that involves the James Webb Space Telescope in preparation for that. And as part of that, we're going to talk about this image that you can see kind of in the slide right now called the Hubble Ultra Deep Field. And we're going to get to see more of it. And Alex is going to talk to you a bit about it right now.
Yes, so the Hubble Ultra Deep Field is a very important image to us in the study of the cosmology and studying the grand universe. It was taken by this instrument here, the Hubble Space Telescope. You can see a little miniature. Hopefully that lighting is good enough that you can see it. But this is the deepest portrait of the universe ever made. So these objects that you're seeing now, most of them are actually other galaxies. There are only a few points of light in here that aren't. The little crisscrosses, those bright points, those are actually stars. But there are 9,996 other galaxies in this image, and they range anywhere from 1 to 12.7 billion light years away. So the light from these galaxies has taken, for some of these galaxies, has taken almost 12 billion years to reach us here on Earth. So these are the farthest and the dimmest objects we've ever been able to see, and it took Hubble a lot of time to actually get these. It took 400 orbits around Earth for Hubble to take this image, and that totaled to about as if you had like a camera open for 11 days straight. So like when you have your camera open, it opens and closes really quickly. Well, Hubble had its camera open for 11 days. And so when we look back at galaxies these old, we're seeing the universe as it was 7 times smaller than it is today. So these are really distant, really faint, and this is basically looking way far back in the past.
Thank you, Alex. We're actually now going to talk a little bit more about the instrument itself, Hubble Space Telescope. You may have heard of it. It's been in operation since 1990, and it's probably one of the most well-known space telescopes, as in a telescope, as you may have heard of, in space. And that has a lot of advantages over ground-based telescopes in that they don't have to deal with the atmosphere and things like that. It's an optical telescope, so it sees the same kind of light that our eyes can see, but Hubble has a pretty big eyeball because it has a mirror of about 2.5 meters wide. This is the first telescope ever designed to be maintained while in space. So you may have heard of the space shuttle missions, which went up and were able to repair any damage or problems that HST ran into. And this has been a really interesting and useful instrument in a lot of science. A lot of the science that our group does is based on the Hubble Space Telescope because one of the lead scientists on it is the leader of our group, Roger Windhorst. This includes the UV Candles Project, which is a study that looks at the star formation in certain kinds of galaxies using both HST data and LBT data, which stands for the Large Binocular Telescope. Before we move to our next slide, we have a little interesting tidbit, a question that we're going to pull up on the screen for you guys.
Yes, so we're actually going to launch an audience poll that you can participate in. And the question is, what is the equivalent light-seeing power of the Hubble Space Telescope? So we have some equivalents here. Seeing a stoplight from New York while in LA, seeing a flashlight on Mars, seeing a firefly on the moon, and seeing the nightlight down the hall. So while you guys answer that, we're going to wait to go to the next slide because then we have the answer coming up. Okay, so the answers are rolling in. A lot of people are saying flashlight on Mars and firefly on the moon. We got about 40% for flashlight on Mars. They're rolling in. Let's see, we're going to wait a little bit more. Okay, and so we'll go ahead and end that. And so most of you guys actually said seeing a flashlight on Mars. So why don't we go to the next slide and reveal the actual answer?
So yeah, that's a very good guess, and I'm hoping the PowerPoint's going to move forward. It didn't because I didn't close out of the poll. Now it will. Essentially, you guys had really good guesses, and I think that this kind of goes back to a metaphor that Professor Windhorst uses, which is a firefly on the moon. That is the brightness of an object that you're seeing when you see some of these galaxies. So if you had something like a firefly, which I don't know about you guys, but I can only see fireflies maybe a couple hundred feet away, but imagine that on the moon, and that is how dim the galaxies are that we're seeing in this image. What's even more incredible and what kind of makes sense when you think about how dim these things are is the area on the sky that you're seeing when you look at all of these galaxies. The area of this image was taken is about the size of your thumbnail if you hold it out at arm's length away from you. It is that tiny area of the dark sky that Hubble stared at for 11 days, essentially, and was able to see all of these galaxies. And this isn't a unique area in the sky. That says that everywhere around us is filled to the brim with distant galaxies, which is pretty incredible. This does make this, as Alex said earlier, the deepest portrait of the visible universe that has ever been made. We're going to look at now a few other images, which include Stephan's Quintet, which is a set of different galaxies that were imaged by Hubble. And something kind of cool about these is that not only are these 5 galaxies kind of close to each other in this image, but there are also many of them are close to each other in space. The blue guy in the top right is actually relatively close to us. You can tell actually because it's blue, but that gets a little more complicated. But the 5 other galaxies where you see 2 in the middle there that are really close together, another one to the bottom right, and then a guy up in the top left, those are actually physically close together in the universe, which is pretty cool. You don't actually see that often. It's also just a beautiful image. I think we can all agree. We then move to M106, which is a It's a galaxy which has been imaged by many different telescopes, including HST, which you can see traced out in some of the reds and kind of the grays that are in the middle of this image. Then the Chandra telescope, which looks at things in the X-rays, and you can see these beautiful filaments of purples and blues that are coming out of the middle and a lot of different points in the galaxy. A couple other telescopes are involved as well, but this is just a beautiful image that we like to share with you guys. We then move on to another project that our research group works on, and this is called SkySurf. It's essentially based on the idea that 95% of the light that the Hubble Space Telescope receives is from pretty close by. It's from different materials that are reflected within our solar system and near our solar system. And that's pretty incredible in that most of that for kind of stereotypical astronomy is just thrown out because we don't end up using a lot of it to study galaxies and other things like that. But a lot of that data can still be used in order to analyze what is really close to us, all this dust and gas and things like that. And so the idea is to surf across the sky and be able to look at all this extra data that's usually thrown out and try to get some really cool ideas about what is around us in the local universe or even, around our star. So I'm now going to hand things over to Alex to show us a few things about the James Webb Space Telescope, which is something our group has been building toward for a long time.
Right. Thank you, Liam. So James Webb Space Telescope is the future. It's the next, it's like the big brother of Hubble. It's going to be the next space telescope. It's been planned for numerous decades. And it's eventually, virtually the successor to Hubble Space Telescope. It's going to be able to see even farther, and that's because James Webb is an infrared space telescope. So Hubble is mainly a visible space telescope, but James Webb sees in the infrared band, so it can see even farther galaxies because those wavelengths have been stretched so much that they're no longer in the visible wavelength. And actually, because of its large 6.5 meter mirror on it, James Webb will actually have the same resolution in the infrared as Hubble does in the visible. So we'll be able to see farther and we'll be able to see clearer, which is a really big advancement for seeing further into the history of the universe. So James Webb, Hubble orbits the Earth pretty close, like most other satellites that we have nearby. But James Webb will actually orbit at what's called a Lagrange point, which is a steady point of orbit away from Earth. And it's actually about 1.5 million kilometers away. So Hubble, we've been able to send missions to repair it, like when we had that big mirror failure when it first launched. But James Webb doesn't get that luxury. Once it's out there, and we just got to hope that it works. So a lot of testing and planning has gone into this mission because when it gets out there, we can't get back to it. It's on its own. So James Webb will actually study what's called the first epoch of light, or the epoch of first light, which is about 200 to 400 million years after the Big Bang. So it's seeing so far away that these galaxies are just a few hundred million years after that Big Bang event. So very exciting. But there's been a lot of prep work that goes into this. There's the Subaru Deep Field Galaxies, which are telescopes in Hawaii. And some of my research, the active galaxies contribution to reionization, which is what I'm kind of studying with Dr. Brent Smith, a lot of that will also be influenced by Hubble Space Telescope. And so there's a lot of very interesting facts about it. And so what we're going to do real quick is we're going to launch another poll. Let me see if I can pull it up real quick. So we're going to launch another poll. And so what is true about the James Webb Space Telescope? It has more imaging capabilities in the infrared. It'll be located at a Lagrange point, has the same resolution in the infrared as Hubble had in the visible, or all of the above. So you guys go ahead and answer that. And then we'll go to talk about a little fun tool that you guys can get for free online that allow you to fly through the deep field. Very exciting. Okay, so it looks like a lot of people are saying all of the above. All of the above is the correct answer. James Webb Space is a really versatile machine for studying these early points of light in the universe. So yes, all of the above, that is entirely correct. And so now back to Liam to talk about our tool, our free online tool.
Thank you, Alex. So as I mentioned toward the very start, let me click back into the presentation. Perfect. So as I mentioned toward the very start, I do a lot of work with this educational tool called AHA, or Appreciating Hubble at Hyperspeed. And basically, this is a free online tool. Well, you download it from online that you can actually get at aha.asu.edu. And it essentially is a 3D simulation of that same image we've been looking at, the Hubble Ultra Deep Field, and it lets you fly through at faster than the speed of light and look at different galaxies. And we're actually going to give you a demo of it in just a few minutes. And this 3D simulation also gives you a lot of really cool abilities in terms of seeing what your speed is, your distance, and you can actually see the universe shift based on these really cool cosmological parameters that we've put into the system. So I've been doing work with putting that in the classroom, and we're going to get to show that to you in just a moment. So we're going to put up another poll, I think, that Alex is going to manage for us, and while I pull up the tool.
Right, so we talked a little bit about this earlier. The Hubble Ultra Deep Field is the deepest portrait of the visible universe ever made, meaning that it can see the farthest objects we've ever seen, it can see the most objects we've ever seen, or it has the most color in it we've ever seen, or it's located near the high dive. Now, that is a joke answer. If you want to vote for it for the sake of comedy, go ahead. There's no wrong answer, but that would be probably pretty close. But so it looks like a lot of you are choosing the correct answer. There's a lot of, yeah, we got the grand majority. So we're going to wait for a few more votes to come in just to give everyone a chance to participate. And so as you can see now, Liam actually has AHA up. So you can actually see it right now. It looks pretty much like the image as it is, but you'll actually get to see it's a little bit more than meets the eye. So yeah, most of you voted. You said it can see the farthest objects we've ever seen. So when we talk about it being the deepest portrait, that is exactly right. So now, Liam, show them how it works.
Thank you, Alex. So we have here the tool, which is our 3D simulation, and it doesn't look like much right now. There's a lot of points of color on the screen. However, I'm going to first point our attention to a couple few things, and then I'm going to really get your mind blown. So we first have our position here, where we have our redshift, which is essentially an astronomer's approximation for distance. It really measures how much an object is going away from us. But as you study more and more astronomy, you kind of learn that everything basically is going away from us. And so you can actually use the speed at which things are going away in order to determine how far away they are, which is pretty cool. You can also see down here in the bottom right that our current speed is 0 times the speed of light, which is good because we're not moving. But if I then go over here and double click on this galaxy, here we go. We're going to fly right over to it. You can actually see this galaxy right here we've zoomed into. It's probably a spiral galaxy, as you can see these arms moving around, and we've moved right up to it in this image. You can also click on the galaxy to get some information about it, and there's a more information link right here. You can see that there's a co-moving radial distance, which is just a fancy way of saying distance in megaparsecs. You're going to have to look up what the conversion of that is, but I'm just going to tell you right now, unlike what you've heard in Star Wars, megaparsec or parsec is a distance, not a time. Anyway, you can then, even from this galaxy, I can then double click on another one and we fly right to it. So this is the really cool thing about this tool to me, is that you can really fly through and just visit almost anything in this really deep portion of the universe. And I think that it's just a really fun experience to be able to go through. So what we're going to do now is I'm going to give us a quick reset. Just let it load for a minute. But we're actually going to start answering some questions in the Q&A as I just kind of fly us through and give you all a nice tour. Thank you all for listening.
Good evening, everyone. We've been looking at the great questions, and please do continue to submit them in the Q&A section. You can send us your questions. We'll do our best to answer all of them. We have a question from Susie, and this is directed toward Alex. Alex, in looking at the Hubble Ultra Deep Field image, are the visible crisscross stars in our galaxy?
Yes, that's exactly right. So all those little small points of light, there are very few in that Hubble Ultra Deep Field. Yes, those are all from our own Milky Way. And the reason there are so few is because, again, like Liam mentioned earlier, it's taken in this very, very dark portion of the sky in what's called the GOODS North Field. And GOODS basically just stands for, let's see if I can remember it, Great Observatories Origins Deep Survey. So it's this area of the night sky that Hubble has imaged and plotted numerous times, and it's a very, very dark portion of the sky. If you go out and look at it with your naked eye, or even with some nice telescopes, you wouldn't actually end up seeing much in it because it's very dark. There aren't many stars in our own galaxy there, so basically all we see out there is other galaxies. But yes, those stars are our own in the Milky Way.
Great, thanks, Alex. We have another question, and it's from Callie, who is 8 years old, and they would like to know, how were stars made in the first place?
Callie, that's a really great question, and the simplest answer that I can give that still leaves you maybe with a little more questions to look up or read into on your own, would be a long time ago, there was, a whole bunch of stuff kind of in a very small space. And then we had an explosion, a big bang, where you had material distributed all across the universe. And basically what happens then is you have all this dust. You can think of sand if it was like a big cloud of sand. And you can have little areas of the sand that there's more sand in them than other places. And you know how gravity makes you fall to Earth? Well, when you have a little more sand here than you do other places, that can pull more sand to fall onto that bit of sand. So that means that then the dust and gas and things like that were whizzing around in the universe fell onto itself until there was so much stuff that it got really hot. And then that really hot stuff, boom, exploded and turned into a star.
Liam, we certainly appreciate your efforts to answer such a big question so eloquently. Thank you so much.
It's a very good explanation.
The next question I'd like to give to you is from Penny, and Penny wants to know about the reference that was made earlier to 5AU. That can be for either one of you to field. Can you please describe or define for us what the term AU means?
Yes, so an AU is an astronomical measurement of distance, much like a light year or a parsec, but it stands for astronomical unit. And basically, it's the average distance between the sun and the Earth. So the distance to Earth on average is 1 AU. And so smaller distances are usually defined like that, or relatively small distances, like distances to planets, some close stars. But most things are too far away that we start going into parsecs and light years. But AU is just basically the average distance from the Earth to the sun.
Awesome.
Okay, and so this one's for Liam. And Jose would like to know, what's the significance of the colors on the galaxies?
That's a very good question, Jose. So I'm actually going to reset us right here to take a look at all this. And you may have heard me mention earlier how you can have, we had that nice image of Stefan's quintet where you had blue galaxy and then a bunch of redder and orange galaxies. Now, of course, there's always a bit of muddying the waters when you talk about color in astronomy, because we talk about so many wavelengths of light. There's so much more light than our eyes can see. So these colors aren't strictly the colors you'd see if you're looking in a telescope. However, generally, bluer things in astronomy tend to be younger stars. So stars that haven't lived as long, or populations of stars that haven't lived as long, or things that are headed toward us. Now, in this image, you're typically going to see a lot of these kind of redder galaxies. This is actually a good example. You can see these galaxies that are overall kind of orange, but then you actually have a little bit of blue in here. And that's because in these kinds of spiral galaxies that are really close to us, we have older populations of stars that are right in the middle and interspersed throughout. But then in the arms of spiral galaxies, you have big populations of younger stars that are being born, and those tend to be bluer. So in that case, we're actually talking about galaxies that are very close to us, but it's a difference in the ages of their stars. If you move even further back, though, into this field, you start to see all of these red galaxies. And these red ones mean that they have populations that are kind of a certain age, but they're also moving away from us very quickly. Then, if we get even further into the whole thing, you're going to see some of these blue objects. And that's because when you see things that are really, really far away, they're actually younger. They're further back in our universe's history. And that means their population of stars is younger, sort of, when we're seeing them than ours, which is kind of interesting. I hope that's helpful.
Thank you very much, Liam. So much to know, so many ways to know it. We have a lot of questions in the Q&A, and I just want to finalize with this question from Michelle is writing on behalf of Marina and Victoria, and they are 10 and 9 respectively. And they want to know, is there any grouping bigger than a galaxy? And what are galaxies made of?
So hi, you two. Very good question. There are groupings bigger than galaxies. The things that are easiest to see are galaxies, and to a certain extent. There's stars, and then there are collections of stars, which are galaxies, which maybe answers the second part of that question, where galaxies are these big collections of stars like our sun and other stars that we see out in space. Most of the ones we see are in our Milky Way, which is a big collection of stars and dust and gas and things like that. But then you can actually have these organized groups of galaxies where you have a whole bunch of galaxies that are sort of like, it's almost like a constellation where you see these loosely oriented things in the sky. And you can actually see that with galaxies where they kind of cluster together due to that same gravity I was talking about before. So these sorts of groups and then super groups, which are groups of groups, are kind of the biggest structures that we can see in our universe.
Okay, and I just want to add to that quickly that Elena also with Marina and Victoria is asking a question, how many galaxies are there? And that'll be our last question of the session.
I mean, as far as our understanding goes, our universe is infinite. There's really no getting a definitive number out of anything because there's an infinite amount of galaxies that we haven't yet observed. But even in our observable universe, I don't think we've come close to even cataloging all the galaxies that we would be able to see in our night sky. We've taken really deep images of this in Hubble, but just look at how many galaxies are in this image alone. There's almost 10,000. So you think, you can make estimates in our visible universe how many we can see, but in the traditional sense that our universe is infinite, there are infinite galaxies. There are as many as you can count and more.
And I think I could sum that up in 2 words: a lot.
Yeah, exactly. Yeah.
Thank you all so much.
Yeah, thank you. And we'll if there are any more questions in the Q&A, we'll be responding to them as text, but we'll pass it back to Rick for now. Thank you so much for having us.
Thank you, everybody. That's great. You guys did an amazing presentation. So I think we know a lot more about the work that the Hubble Space Telescope did. I hope everybody is planting in the back of their brain the term James Webb Telescope. That's the next one. That's the one we're looking forward to. We'll be launching in a couple of years. And when it shows first light, it should give us an amazing view, sort of something of things we've never been able to see before. And by virtue of some of the physics that Liam and Alex were talking about. So that's very excellent. Thank you. The next part of our program is a lot closer to home. We're not intergalactic anymore. We're talking about a constellation in our own galaxy. And I think it's one of the most famous, one of the most recognizable, one of the easiest to find constellations in the night sky. It also happens to be a wintertime constellation. So we get an opportunity tonight to learn about and welcome to our sky Orion. And I'm going to turn the microphone over to Alicia Hyatt and Spurti Katsare, and they will explain to you or talk to you a lot about sort of how to find and some of the important things about Orion. Thank you, guys.
Thank you so much, Rick. Hi, everyone. I'm Alicia Hyatt, and I'm going to talk to you about Orion the Hunter, a pretty famous constellation. I'm sure you've heard of it. But Orion is a constellation that we have, or that we're able to see here in North America during our winter months, roughly from November to about February. And so right about now. And so what I want to encourage you to do is go out and look at the night sky and look at Orion, because it is one that we are able to see here, especially in Arizona. Through the light pollution, we can still see it. And so I encourage you to, there we go. I encourage you to go outside and take a look and see if you can find it. And hopefully you can find it after this presentation. And so right around 8:30 or 9 o'clock is when Orion will be above the horizon, and you can go ahead and look for it. But in order to find Orion, I have to show you how, right? And so one of the easiest ways to find Orion is to look for this hourglass that I've kind of lit up for you here. And so as you can see, there are 4 really main stars that make up this hourglass, but it does cross through 3 here. And so it is 7, we are talking about the 7 brightest stars of Orion, or the 7 most prominent stars that we're able to see of Orion. And that's a really easy tool to identify this constellation in the night sky. And so what I'm going to do is I'm actually going to stop sharing my screen super quick, and I'm going to share with you a different screen. There we go. Let's make it full screen. Awesome. Okay. There we go. Alrighty. So here we are looking at the eastern part of the night sky. And so what I'm going to have you guys do is just take a moment and look at the screen and try and use the hourglass idea that I just showed you in this model. I know it's kind of confusing, but just try and spot Orion using the hourglass that I mentioned. And if you haven't found it yet, I'm going to go ahead and light it up for you. It's just right over here. Oops, I'm going to go ahead and fly in just a little closer. So here's Orion. And so a really easy way to identify it, like I said, was using the hourglass. So you can see 1 corner, 2 corner, 3 corner, 4, and then it would, if it were prominent, the hourglass lines were prominent, you would see it cross through these stars in the middle. And so the 4 main stars or the 4 rectangle stars, the outer stars that make up Orion are Betelgeuse, Bellatrix, Rigel, and Saph. And so these stars are really neat because Betelgeuse and Rigel are pretty prominent in color, and you're actually able to see them in the night sky just with your naked eye. So Betelgeuse is a little bit redder, and you can see a red hue or a red tint to it in the night sky. And then Rigel is going to be a little bit bluer in the night sky. So that's another way you can identify this constellation, is by looking for the 2 stars, the red star and the blue star. And so another super easy way to identify Orion is by his belt, right? We have these 3 stars right here that make up his belt. It is the Alnilam, the Alnitak, and the Mintaka stars that you can see here that make up his belt. And if you're wondering what I mean by belt, or if you're wondering what lower sword means, there's a lot of mythology that goes to these constellations. And so to discuss mythology a little bit more, and specifically the mythology of Orion, I'm going to pass things over to Spoo for a little bit, and she's going to explain to you the mythology.
Right, thank you, Alicia. So Orion is a very bright constellation. Everyone can see it with the naked eye, and it doesn't really need much effort to recognize or identify the constellation in the night sky. I'm going to quickly share my screen. One good thing about astronomy and constellations, especially, is that they're a lot closer to people who are from a non-science background. So it starts with this. It starts with constellations. I've always been interested in astronomy, but it definitely started with constellations. And since they're made up patterns, they go way back into history. So Orion, being one of the brightest constellations, is also has also been observed to be drawn in caves in the Stone Age. So Orion is a really, really old constellation, and there are some fun stories that go with it. So as you can see, this is Orion in the night sky. This is actually tonight's night sky. So this is happening outside right now. You can go outside and take a look after the presentation. So let me just pull up the art really quickly. So this is Orion the Hunter, according to Greek mythology. So as you can see, Orion was a very great hunter. He was one of the best hunters there were back in the day, and he suddenly got a little arrogant. He claimed to be so good that he was gonna kill all the animals on the earth, and the earth goddess was furiated, and she ordered Scorpius, the scorpion. She ordered him to kill Orion to save all the animals. And to this day, Orion and Scorpius are on opposite sides of the night sky. So they say that Scorpius is still chasing Orion, and whenever Orion rises, Scorpion is on the opposite side setting, or then whenever Scorpius rises, Orion sets, meaning that he's trying to run away from Scorpius. So another story that goes with the Greek mythology is the same characters, but it's just a different version of the story. That would be Orion and Artemis were in love with each other, and Orion, being a hunter, he tried to kill all the animals just like in the previous story, and the earth goddess got really mad, and she sent Scorpius, and Scorpius actually managed to kill him. But Artemis, being in love with Orion, she was very upset, and she being something of a goddess herself, she revived Orion with the help of Ophiuchus. Ophiuchus is another constellation which is between Scorpius and Orion. So with the help of Ophiuchus, she revived Orion, and she then put, to commemorate her love, she put him up in the night sky along with Ophiuchus, who she wanted to thank. So this is one of the Greek versions. So in this image, you can see Orion holding the hunt. There are some. So this is a really ancient image that you can see. This is what you can see. What he's holding is, in some images you can see it as a huge sword, or in this it's like something to beat it up with. It's a lion. It could be a tiger. So the version really varies, but the belt and the dagger, or the small sword, almost remain constant in every version. So another image is he is not holding his hunt, but rather a shield. So it kind of makes sense. And Orion, to be honest, is one of the constellations which makes more sense when it comes to shape. So there are a lot of constellations which are very hard to imagine when they tell you stories, like maybe a bear, or whales and seas and monsters. So they're really difficult to imagine. But Orion, you can very easily imagine from the constellation itself without needing art there. So another really exciting story about Orion from the Egyptian culture is that Orion was related to Osiris, which is the god of the afterlife, according to Egyptian culture. And every solstice, Orion was seen to rise just before dawn. So they said that the god of the afterlife was walking on the horizon just before the dawn. So kind of scary, but also very interesting. So that also gives you an idea about the different locations and how it can be, or how it was viewed back in the day, and at different geographical points on the earth. So it's different for everybody. But since the constellation is so bright, that we have a lot of stories. Another very interesting story which I would like to share is from my culture. So I'm from India, and we have this story where Orion is actually a deer. So let me just pull it up for you. Okay, this is a. Please pardon my drawing. This is just to show you what's going on. So right there is the deer's head. These are its forearms, and these are its hind legs, and this is the body of the deer. So now the story goes, a hunter was on I think it was in a very sacred, but not forbidden, but yeah, it was a sacred forest, and the hunter was in it, and he was trying to get his prey and get his hunt, and he spotted a deer, and the deer pleaded to the hunter, saying that I have a baby waiting for me that I have to feed. So please let me return. I'll feed the baby and I'll come back tomorrow. So the hunter agreed, because the deer pleaded with all his heart. So the hunter waited on a tree of bay leaves, which are considered to be sacred, I think. So the hunter waited all night and didn't eat anything, which kind of turned it into a fast. So the next day in the morning, when the deer came back, the hunter was really pleased with the deer's honesty, and that it kept its promise and it came back. So the hunter did not kill the deer. So that is one version of the story. And then since the hunter almost fasted all day, the gods were happy, and then they put both the deer and the hunter in the night sky. Another version is that the hunter actually killed the deer, and but the deer was honest. So the deer came back in the morning, but the hunter still killed it. So to commemorate the deer and not the hunter, the gods put up the deer in the night sky. So this is the head of the deer, as I said, the body and the arms. And this you can see is like a cut. So the belt essentially becomes like a cut in the deer's body. And this is the dagger that the hunter killed the deer with. So there are a lot of different versions of Orion. Orion is literally the most famous constellation, and for good reason. There are a lot of interesting and scientific facts that you need to know about Orion. And for that, we're going to go back to Alicia. So take it over, Alicia.
Thank you so much. I'm just going to start my video. Okay, awesome. Thank you so much, Spoo, for that wonderful presentation on Orion's mythology. Thank you. With that being said, you may be wondering, why do we care about Orion? Why is it significant? Well, obviously, as I mentioned earlier, you can see Orion throughout the winter months in the night sky, but there's a lot of science that the constellation Orion gives us, or things within this constellation give us. So for example, looking at Betelgeuse over here, we talked about Betelgeuse the star being red, right? And so I didn't give you all of the details. Betelgeuse is what we call a red supergiant. Excuse me, a red supergiant. And so what that means is that Betelgeuse is is nearing towards the end of its life cycle, and it's gonna kind of huff and puff and do this beautiful cosmic explosion. And Betelgeuse is going to be what's called a supernova. It's gonna go supernova and explode. And so it's going to be so energetic and so catastrophic, if you will, that we'll be able to see it actually during the daytime for up to half a year. So it'll just be so bright that even during the day, it'll be prominent. And so we don't know exactly when that's going to happen. Scientists kind of go back and forth on that date, but it is something really exciting to kind of keep an eye out for in the news as, Betelgeuse maybe dims or brightens. That can kind of be an indication. So that's something that's interesting. But in addition, if I scroll over a little bit and fly in, you may be wondering what this M42 is in the lower sword. And so M42 stands for Messier 42, and it is also known as the Orion Nebula. So what's really neat about the Orion Nebula is that you can identify it, but with the naked eye, right? You can see it normally when Orion is a little bit higher in the night sky and you're able to get a clear view. You can kind of see this little smudge under the belt of Orion, and that'll be the nebula. And what's beautiful about this is that it's a stellar nursery, right? This is where stars are born, and this is where they grow, and we are able to, in a sense, grow with them, if you will. We're able to use our technology as it grows to track these stars and identify them and catalog them and do as much research as we possibly can to learn how stars interact with each other and how they're formed in these conditions. So we're able to do a ton of science just by looking and studying Orion. And we may not be seeing these stars as they are right now or as they're forming. We may be seeing them in the past, but we're still able to see them, and we're still able to monitor them for the next decade or next 100 years and learn that science as well. So that's something that's really interesting, or at least I think is really interesting. And so I really do want to encourage you all to go outside, go look for Orion tonight after our program, and continue to look for Orion for the next few months. You can look for it in the eastern sky every single night, but just know it's going to be about 4 minutes earlier each night to account for the changing seasons. So go out 4 minutes earlier, or 2 hours earlier at the end of the month if you're starting new. But please, please, please go outside and explore. So with that being said, I'm going to pass things back over to Rick.
Thank you, Alicia. Oops, let me turn off my other mic. Alicia and Spoo, Alex and Liam gave a nice introduction about what they're working on in school. And can I ask you guys to do the same thing? I'll start with Spooty.
Yes, sure thing. My name is Purti Katre, and I am a graduate student at ASU. I am majoring in aerospace engineering, and I have a few ongoing projects about propulsion. So that's about it. So I'm not an astrophysicist. I make the the cool stuff, the rocket part, and I get to launch stuff into the night sky.
Excellent. Alicia.
I'm Alicia Hyatt. I study astrophysics and biology, and I also work in Heather Troop's lab, Dr. Troop, and it's the DICE lab. So it's the Drylands in a Changing Environment lab. So we study desert environments.
Excellent. And Alicia has also been a member of my staff for several years, ever since. Were you a freshman when you joined us? Is that right? So,
Yep, my second day of classes.
and now she actually has graduated with a BS both in astrophysics and biology, and and she's hanging around. She's going to do something else for us as we go forward. So excellent. Thank you guys very, very much, and thanks really for all of your help on making these virtual night skies sort of alive. So we've kind of reversed things, if you've noticed. Oftentimes the students, Alex and Alicia and Spoo, will kind of monitor the questions and sort of work in the background and do all that kind of stuff. And we've kind of changed it around. So now the staff is actually doing all the background work and the students are presenting. And I think they did a great job. I'm going to just sort of take us kind of to the future a little bit. I'm going to talk a little bit about some things coming up and what to expect from the virtual night sky over the next several months. And
Rick, can I interrupt you real quick?
yeah, go ahead.
Sorry, folks. There was a little thing that I forgot to mention earlier was with the AHA tool, if you want to go install it, it works really well on Windows computers, but because it's a Java program, you need to have Java installed, and that can be a little funky if you're on a Mac machine, so an Apple machine. So just keep that in mind. There are instructions on the website and also in a paper that you can find there on the tool. And we're going to update the website soon with some kind of more friendly instructions and things like that. So if you're on a Windows machine, it should work just fine as long as you have Java. On a Mac, it can be a little more complicated.
All right, thank you, Liam. Yeah, that's actually, and I noticed that in the chat, as Liam was talking very at the beginning of the program, we included the website where you can go and find that. So I encourage you to do that. You can kind of just go fly around in sort of the dimensionally, if you want, through the ultra deep field, like Liam was doing on the screen. And that'll be a really good tool for you guys to play with. That's very fun. We also will include that website. I think we send a survey out in the next couple of days. So we'll include some information for you to kind of look for it there as well. I wanted to suggest to you, this is the season of the Geminids. So a couple of weeks ago, Spurti gave us a presentation on the Leonids. This is a meteor shower. The Leonids are sort of like known for the middle of November. The Geminids are known for being a December meteor shower. They actually start about now. And if you remember her presentation, right, these things have a span of time where you can find these meteorites or see them in the night sky, but they usually have a peak or they have a maximum, and the maximum for the Geminids is going to be December the 14th. The reason to bring that up now is that it's 2 days before our next meeting. So we will be doing this night sky presentation 2 Wednesdays from tonight on the 16th. So it's something to go look for. So now you have 2 things. I'm going to introduce a third too. So you're going to about 9 o'clock, just see if you can sort of find Orion. It should be well above the horizon, very easy to see. By about 9 o'clock tonight, it's above the horizon, about 8:30. Give it another half hour to get up there. Put on a really warm coat because things are cold out there. This is a really great time of year to look at the night sky. And you also have to put up with more cold. But this time of year in the valley, in the Phoenix area, we have really crystal clear skies. It is the best seeing there is in our particular location. And of course, you have to be able to put up with the cold to do that. They tend to go together. And especially tonight, after a big, huge wind blows all the dust out of the nighttime sky, the stars that are rising now, Orion, some of the ones that are following are the ones we're going to be talking about into January and February. And the brightest stars in the sky tend to hit us during these winter months. And so we get the double benefit of having nice, clear, crystal clear skies and bright stars at the same time. So we have all that to look forward to. Watch for Orion. Watch for the Leonid meteor showers. And trick to that is to go out late at night, if you will. Really, again, put on extra jackets because it's going to be cold. Give yourself a little bit of time to have your eyes adjust to the dark. And then on the 14th, not only is the Geminids one of the best meteor showers because of the number of objects that you can see during any given hour during the highlights. In this particular case, it peaks around the 14th, as I said, and that's also a period of a new moon. So you don't have the competition of the moonlight this particular December. And so it's going to make this particular meteor shower even better. We also have something to look forward to this weekend. There is a mission that we're interested in. Our director is Miyanache Wadwa. She actually is on the science team of a mission that's actually run by the Japanese Space Agency. It's called Hayabusa 2. Hayabusa 2 was a sample return mission to an asteroid. You might have heard on the news several months ago that it had a successful grab. It was able to get some material, and it is due to land back on Earth on Saturday, the 6th, this weekend, and it will be landing in the Australian desert. Once done, that material from this particular class of meteorite that we have not done before will be examined by teams of scientists around the world. And we're proud to have our director is also a meteoriticist. And she, you might remember her from a program about 6 weeks ago. We had a discussion about meteorites, and that was Minnie, as we call her. And so she's part of the science team, and that will be kind of cool to see. On the 16th, when we meet again, we're going to actually sort of do a bunch of different things. We're going to talk a little bit about some native stories. We've had comments from our audience over the seasons that native stories and some of those things that are about Southwest culture have been sort of important. Many of you might know, you might not know that traditionally those stories aren't told outside of the wintertime. So now it's getting cold enough and it is more appropriate. So we're trying to line up some storytellers and some things for next week to help introduce that. We'll introduce the idea of the winter solstice. We're meeting on the 16th, but the 21st is the winter solstice. It's our last meeting of the year. We'll talk about the significance of the solstice and what makes the solstice happen and why it is when it is, and some of the culture around that. And then I'm going to switch screens here really quickly if I can. I'm going to try to do this. Those planets we've been watching, you remember Mars, Jupiter, and Saturn have been in the night sky. Oops, I sort of just shared the wrong screen. Hang on a second. Let me try that again. And at the end of each session over the last couple of months, I've been kind of showing you this particular image here. This is a view of your night sky or your solar system. And those planets are blown up really, really big. They're not this large in the night sky, but it gives you a chance to sort of see where all of these planets are in their orbits. And if you go out tonight or have been watching over this course of the last couple of months, you've been noticing, I hope you've been noticing, that Jupiter and Saturn in the south, a little bit towards the west, have been getting a little bit closer to each other. They have actually sort of been moving in such a way they were sort of even horizontally aligned a couple of months ago, and now they're sort of like coming up and becoming more vertically aligned. They're also getting dimmer. And the reason for all of that stuff going on is this particular juxtaposition that you can see in this particular image. The Earth is in its orbit. We're moving away from those planets. As we sort of heard, the Earth is moving towards me or towards you in this particular image. The Earth is going to sweep around, turn the corner, and go behind the sun. So the sun is going to get between us and those planets. The fact is that we're moving a little bit laterally, a little bit towards the right now, means that those planets are going to get even closer to each other. You can see that we'll be kind of moving into a position where they're almost equally aligned. We'll be talking about that a lot on the 16th. So 2 weeks from now on Wednesday, we'll give you some clues on what to look for. That conjunction is going to happen coincidentally on the winter solstice. So on the 23rd, those two planets will be as close as we usually see them. I mean, this is going to be really quite an event. In fact, they are 6 arc minutes across in separation. And that means that it's about 1/5 of the width of the moon that these particular planets, to just the casual observer, they're going to look like they're actually touching. They're going to be like right next to each other. Combined with telescope or binoculars, you should be able to see a little bit of the separation and see what's going on. So we have lots of really cool stuff to show you about that, and that will be coming up. Our hour is over. I want to thank everybody that participated. I want to thank everybody that joined us this evening. We will have the one more VNS program, the Virtual Night Sky program, on the 16th, and we'll take a break over the holidays. And then we have scheduled every other Wednesday night starting January the 13th, same time, Wednesdays at 7:30, every other starting the 13th, and we've programmed it out through the end of the school year, or the semester, all the way into June. So we'll look forward to having you come back. Please take the survey. Don't forget that we need your comments, and we use it to sort of help put the program together. And I really appreciate everybody joining us. Thank you very much tonight.